Record on this computer. Welcome to the lesson about inheritance. We have a very important poll I need you to fill out. Deep dish pizza is a type of pizza. Very relevant to today's lesson on inheritance. Let's start off with a little warm-up. When you think of the word inheritance, what does it mean to you? And I'm not talking about a programming context, like a real-world context. What is the real world? I don't know. It's been so long, but what does inheritance mean to you in a real-world context? Just write down any thoughts here. When you do, create a little sticky pad, create a thoughts. Oh, how can you do that if you don't have the link? I'm putting the link in the inheritance thread, the Jamboard. There you go. Anonymous Manatee joined. I'll give you 4 or 5 minutes for that. When you're done, draw your best pizza for Mike. Here, just whatever you think pizza looks like. Draw your best pizza for Mike when you're done. What you want to focus on is when you think of the word inheritance, what does it mean to you? What's the meaning of inheritance? Merriam-Webster. Meaning, whatever. I'll give you a few minutes for that. Turn some music back on. I'll pause the recording for. I do.
Rad. We do too.
Cool. I'm recording and sharing my screen. Haha, nothing went wrong before this. None of the lesson was missed. So the example Lee gave is a plant could be like the parent class, right? State might be leaves. Behavior might be photosynthesis. When I think of maybe a child class for this, I think maybe I picked the weirdest looking plant, right? It has something that is sort of like leaves, where it like does stuff. It also does photosynthesis, but maybe the type of leaves are like a little bit different. They look different and are prickly. And some other stuff, right? How they behave, like they might have additional behavior that isn't part of the parent class or additional attributes about them. But like water held. What's the one thing called where water like runs up? Whatever. We'll stop doing ithric biology stuff.
Capillary action.
Capillary action. Thank you. Okay, capillary action. Sorry. Cool, great example. Does anyone else have an example for me? I see some hands raised. Matt H. Not there's another Matt. Go ahead.
I'm muted. So we thought of the example of water. The parent class could be water itself, and then maybe bodies of water could be a child class, and then you could even sort of like tier it beyond that, like rivers, lakes, and streams, and then you could even get into specific examples thereof. States would be like frozen or liquid. Behavior would be like flowing or chasing, like if you're chasing waterfalls, which like you really shouldn't. You should stick to like rivers and lakes if you're used to them.
Nice. So like this example, I would I do like this example. I would think like bodies of water might be the parent class, and then like a river, a lake, a waterfall might be the child class that inherit from it. No, I think just water is fine, and like different types of bodies of water would be the child class, like lake, river, we're used to waterfalls. Cool. That's example. Good cultural reference for 80s and 90s BBs. Oh my gosh, it's 1:28. Let's take a break till 34 after. I'll see you then. like I was saying, a teaching assistant is a good example to use inheritance because it is a type of instructor, and we care about the state or instance variables. A teaching assistant should also have all these instance variables, and they also be able to teach a lesson and grade projects. As both state and behavior, so you want to inherit. And now we're just showing us the instructor here. They can teach a lesson. If you teach a lesson that's too long, they'll tell us so. And they can also grade projects as well.
Is it grade projects?
It is grade projects, but I'll call it grade project. Makes a little bit more sense. Oh, I'm in the pry. I have to reload it. Nope, can't do reload. All right. Anyways, it's grade project, singular. We'll change it to that. So how do we implement inheritance now that we have a good use case for it? Class, the name of the class here, which is called teaching assistant. And we use this little less than sign. This is say, hey, this teaching assistant class, please inherit from the instructor class. Please inherit from the instructor class. Now, what does that give us? It gives us all the methods and state we care about from the instructor class itself. We initialize this. We need the same arguments that are in the instructor class. Let's put this over here, which are the name, the mod, and the traits. And then to initialize this teaching assistant, we have to do what's called the super method. Oh my gosh, what is the super method? The super method says, hey, teaching assistant, what class do you inherit from? It inherits from the instructor class. And so super says, call this initialize method in the instructor initialize, the class you inherit from. So the instructor is the super class and the teaching assistant is a subclass. Similar to parent and child, right? Teaching assistant is the child class and instructor is the parent class. So what super does is say, hey, look at my super class or my direct parents class. Use that initialize method and pass in the name, mod, and traits. And I'll show you this in the runner. Let's create a teaching assistant. Oops. Let's create a teaching assistant. New. The name, Bob, is a teaching assistant. The mod they are is 1. They like gambling, coffee, other stuff. Let's assign this to a variable. We'll call it TA. I know you probably shouldn't abbreviate too often, but in this case, I don't want to write teaching assistant again, just for this example. We have to require the teaching assistant. That's why. Lib teaching assistant. Show it again. Cool. We've created a new teaching assistant that inherits using the lesson side from the instructor. And then so we can see the teaching assistant has the same behavior as a class that inherits from the instructor class. We have the teach lesson method we can call. Bob can't teach a lesson for that long because it's more than 180 minutes. If you do less than 180, Bob's going to teach you real good about inheritance for 100 minutes. Also, the teaching assistant has a great project, right? It has all the same behavior from the superclass or the parent class. Fellowship. This person is grading Battleship. Probably could use name here instead, but so as you can see, they have all the same methods that exist on the instructor class. And so I wanted to try to make this a little bit clearer. Super delegates to the superclass's inheritance method. Therefore, we need to pass it all the arguments that exist in its initialize, the name, the mod, and the traits as well. Tia, go ahead.
Do the arguments in the initialize statement and the super statement always have to match?
Let's try it out. Let's see. Wrong number of arguments given 2, expected 3. So we're giving 2 arguments here, it expects 3, so the answer is yes. We have to give it 3 arguments. The subclass or child class has to pass to the super method the same amount of arguments that initialize this, the parent's class initialize method takes.
And is it the same in reverse?
Is it the same in reverse? No, because, well, I think the question is, let me make the distinction. The teaching assistant inherits from the instructor. The instructor does not inherit any behavior from the child, right?
Well, I mean, let's say like the instructor has name mod traits. Can the teaching assistant just have name and mods and not traits?
No, it cannot. No, it cannot. Because what the teaching assistant does, it inherits all the same state, right? The instance variables here, and all the same methods or behavior, the teach lesson and the grade project. So it doesn't really have the option, similar to, I didn't really have the option to like choose a different type of color hair. It's like I want the eyes and other characteristics, physical characteristics, but I didn't want the black hair. Please, can I just have brown hair instead? There might be a way to hack it, if that makes any sense, by saying, hey, at name is like something different, right? But I would not suggest doing this. Right? You could just specify, hey, I actually just want this to be a different name, like override the name instance variable from instructor. This isn't a pattern you would generally do or follow, because when you use inheritance, the use case for it is you want all the same state and all the same behavior.
Okay, I guess I'm a little bit confused then. So if I can run through an example, we did languages in our breakout room. So it was like Spanish, English, French, whatever. So like, let's say you have age is a state. Are you saying that each language can't have its own distinct age, and you could put that in an adder reader and call it for each language and get however old each one is?
Each language can absolutely have its own age, right? So here, let me show you an example. Let's add an adder reader here for name. Exit out here. Let's run our file again. We're creating a new instructor, Mike, right? He has his own name. I'll just get the previous command here. We're creating a new teaching assistant, Bob. teaching assistant also has their own name.
And why would you not put the name adorator in the teaching assistant?
Because we're inheriting the method adorator from the instructor, right? We're
Okay.
saying, hey, teaching assistant, inherit all the same behavior like as the instructor. That's what we're doing with this lesson sign, right? And then so now the teaching assistant has the same instance variables, right? But the instance variables change depending on which instance you create, right? And then so Bob here, or the teaching assistant, Bob, has a different name than Mike, as we saw here. Aaliyah, go ahead.
Does the child class, so like TA, not inherit the initialize method? Like, why do we have to make a new initialize in TA?
Why do we have to make a new initialize in TA? That is a good question. Let's try it out. I think you still need to call the super class, the super method to say, hey, this is the initialize method I'm going to use explicitly. But let's find out. Actually, that makes this, okay. Actually, my guess is that the teaching assistant can just use the superclass as initialized without specifying specifically, but let's see. I can. Look at that. I think the reason I gave you the super example is for the thing I'm going to show you next. Good point, Aaliyah, though. So you don't need to define initialize if you're going to just use the super classes initialize method as it exists. But, and this is why I showed you super, but what if we want additional attributes on teaching assistant that don't exist on the instructor? For example, they have a mentor who is also assigned to them. That is when we would need to create an initialize method. We want additional attributes or instance variables on our child class or subclass. Then so here, line 4, we have a mentor who's also an instructor assigned to them. And so I'll show you an example here. Let's run our file again. Let's create our teaching assistant, which is TA. Oops, wrong number of arguments, right? Because we are specifying a mentor argument that they need. And so that'll be the instructor Mike here. So now the teaching assistant, as you can see, has a mentor, and then we use the super method to do the initialize for the other attributes. Any questions on the super method? Aaliyah bringing up a good point of, if you don't have any additional instance variables, you don't need to create an initialize method for it. Regina, go ahead.
So let's say you do have a class, this class teaching assistant that inherits from instructor, and you don't want to add anything to it. And it's what, like 2 lines of code, I suppose. Is it normal to create its own RB file, or is this a case where you can put it, I guess, inside the teacher, the instructor file?
Or Yeah, that's a good question, Regina. I would say you create a child class. Let's say teaching assistant. If you want to define additional behavior responsible for time that's occurring time, and or additional state, or for some reason you want to modify existing methods in that parent class for some reason. You want to modify existing methods in that parent class. So let me show you another example. Let's say a teaching assistant can only teach for 100 minutes or less, right? They're new to teaching. We try to give them, let's just say 90. They're new to teaching. They're not used to the rigors of answering questions, Zoom management, all those sort of things, right? They're kind of new to teaching. That's why they're a teaching assistant, right? Let's say a teaching assistant can only teach for 90 minutes or less. Well, maybe you want to modify the method teach lesson for that teacher. And so instead of saying if duration is greater than 180, say if it's greater than 90. I'm going to give you this example and tell you how you might refactor it. Let's just copy and paste this. You know what? Let me do it the smart way. I'll show you the smart way. Let's say maximum lesson length. The instructor has an attribute like maximum lesson length. Yeah, that's the way you would do it. All right, I'm not going to do this example just because it doesn't make a lot of sense. But for some reason, if you want to modify a method that exists in the parent class, you could do that in the child class if it was different for some reason. I didn't modify teach lesson because it just seemed like a very silly example. So I'm not going to do that. But also, like I mentioned, it's for the extension of behavior or new behavior. So the teaching assistant, one of their sole responsibilities is to tell us the current time. And then the method might be like, hey, that name is telling us the current time is time.now. Right, here's another use case for the child class is they have different behavior or additional behavior than the parent class. The responsibility is to tell us the current time. And so if we run our runner file again, let's create our teaching assistant. Oh, maximum lesson length, we got rid of that part. Create a teaching assistant again. Probably should just put this in the runner file at this point, but there we go. We have our TA, our teaching assistant, and they have a additional method called current time. Bob is telling the current time is this weird time format. One thing I want to mention is it doesn't work in reverse, right? The parent class doesn't have access to child class's methods, so it can't call current time. Cannot call current time. All right. I'm going to give everyone a 5-minute break, and then I'll come up with an example of how we might modify the parent class's method and talk a little bit how method lookup works in Ruby. 5 minutes till 3 after. We'll see you then. All right. Not quite 3 after, so I'll wait. Susie, go ahead.
Bob. So does inheritance only happen between a parent and a child class? Like when you have 3 different classes interacting with each other, is inheritance still happening? Like, for example, like the player class, team class, and like World Cup class from that practice I see, like, is there any inheritance happening there because like the team is no, okay.
Those are
I
just
don't know if
different
I'm
classes interacting with each other.
okay, gotcha.
So inheritance should follow the rule of like, do we want the same or similar behavior from the parent class? Do we want the same state from the parent class? And the child class is like, yes, I might have some additional state and some additional behavior I want to implement. And it follows the is a like test, right?
Got it.
The example like deep dish is a type of pizza? Question mark? Yes, it is.
Got it. Okay, so only with subclasses and instances, this would be.
Yeah, subclasses
Okay.
and instances. Yeah.
Okay,
I
thank
think
you.
the World Cup independent challenge you did is more of like how do classes like that's more dependencies, right? World Cup has a team dependency, and the team has like a player dependency, right? And that's
Yeah.
how you think of it.
Okay, thank you.
All right. Super contrived example. Let's say the base parent class here, right? The teach lesson, I know this is just a string, but do your best to follow along. The process for them teaching the lesson is like they come up with their own lesson plan. It's neat and really engaging, and the class is moved, inspired by the educational beauty. That is how all instructors will teach their lessons. But the teaching assistant, they're new to teaching, right? And then so they might want to override the parents' teach lesson method, right? They might want to override in some way. It's like just use the which are really great lessons, by the way. I'm not knocking the lessons that are on the Turing School of Backend Design. They're all great. Just use the curriculum already created for you. Since I am new to teaching. Right? Maybe the teaching assistant wants to teach the lesson in a different way. In this case, it's maybe because of their lack of experience in teaching, or they're fairly new to programming, right? They're going to want to override the parents' class teach lesson method and implement their own way of teaching. So there might be use cases where you want to override the behavior of the parents' class method, teach lesson in this case, with something that is more specific or unique to the child class. In this case, a teaching assistant just wants to use a curriculum already provided to teach their lesson. Will you do this very often? No, but it's an important concept to know. Why is that? Well, part of it is testing your knowledge on how method lookup works for instances. How method lookup works for instances. So TA stands for teaching assistant here. If I call the teach lesson method or invoke it, which teach lesson will be used? The one in the instructor class or the one in the teaching assistant class? In the chat. If the teaching assistant is teaching a lesson, which method will they use? The one in the teaching assistant class, right? Just use the curriculum I already created since I am new to new line teaching. Right? But if I delete this method, if I delete the method in teaching assistant teach lesson, and then I call it teach lesson on the teaching assistant instance, what method gets used? That's correct, the instructor. Let's dig a little bit deeper into Ruby trivia. What if there is no teach lesson method on instructor? Let's exit out here. If I call teaching assistant teach lesson, yeah, we'll get an error for sure. We'll get an error. What class does teaching assistant look at first to find if it has a teach lesson method? Nice, parent. Good luck. Godspeed. Yes. The teaching assistant instance looks at the teaching assistant class first to see if it has the teach lesson method. What class would it look to next to see if it has the teach lesson method? What class would it look to next? Yes, instructor. Why the instructor? Because it inherits from the instructor class. What class would it look to next after that to find the teach lesson method? I don't know. I don't know. Probably the kernel, maybe? I don't know. Yeah, the object. Whatever class instructor inherits from, right? But it'll continue to look up those class chains until it gets to the kernel object, which Richard talked about there, which is like the global Ruby object. If it doesn't find the method there, it returns an error, goes, undefined method. That's how undefined method works. Yes, Sammy, if the instructor had ancestors, then it'll look there, right? It's like ancestry.com a little bit. I'll look at my parents for the heritage and their parents and their parents and their parents and their parents until something. Who knows? The answer is 42, whatever. So that's how finding the method definition works, right? It looks at the current class, then that parent's class, and continues to look at those parents' classes until it gets the kernel object in Ruby, which is a global object. It says, I don't have the method. Sorry. And one thing I want to show you is how do you see if a instance is something? Well, similar to RSpec, which you've seen a lot. You can just use the is a. Is a teaching assistant is a type of instructor? Yeah, it is. Is it a type of teaching assistant? I hope so. Yes, it is. Whew. Then you can use the is a syntax to see, is it from this ancestry, right? Is it from this ancestry? All right. No more questions. I'm kidding. Now is your turn to implement inheritance. In your Slack chat, I have given you the lib instructor class, the base class, or the parent class that you're inheriting from. I want you to implement child classes for these types of instructors. An anchor who is responsible for the following. It has state that tracks what lessons they're responsible for and creating the curriculum for. A method that tells us the instructor's name and what lessons they're responsible for, creating the curriculum for, and telling us all about their interest. I want you to create an associate instructor child class responsible for telling us their name, but saying it in all caps. Having a state called students, that's an array of students that is passed in as part of initialize. And telling us how many students there are with behavior called student count. That gives us back an integer of number of students. In your breakout groups, I want you to implement these children classes of the instructor class. Any questions on what we're doing? Give me a big thumbs down if you don't know what we're doing. Big thumbs down. Also, I want to answer any other questions about inheritance before we get to breakout groups. I mean, I'll answer them after as well, but are there other questions about inheritance? Noah, go ahead.
What happens when you call class on the TA instance? Do you get 2 answers?
What do we think in the chat? On the teaching assistant instance, what will happen if I call class? In the chat, what do you think? Put your guess in. Let's guess. Let's use our brains. The more we guess, the better we get at guessing. Let's see. I have no idea. I assume it's teaching assistant. It is teaching assistant. It is teaching assistant. Is there an ancestor method? I thought there was. I don't see an ancestor method. By the way, if you want to know what methods exist on the instance you're on, you can just call methods, and I'll show you every single one. Whoa. Okay. Anyways, put you in your breakout groups. Here we go. I'm recording. Welcome back. Does someone want to, you know what? Let's pick Lawrence's group. Lawrence, Molly, and third person that was in there, Sammy. Will you show us your anchor class, please?
Can you hear me?
Yes, I can. We'll just do associate instructor since we're already here.
Oh, okay.
Okay, cool. All right. So line 1, what is going on that group? Describe to me as best as possible.
So we created our associate instructor class, and then we called its ancestor, the parent class instructor.
Yep, so it inherits from the instructor using the less than sign. Cool. Lawrence, what is the super method doing on line 4?
The super method is using the inherited methods from instructor to set the name, mod, and traits that were passed to our associate instructor when it's created.
Yep, super close. It uses the inherited class, in this case, the instructor, right? Initialize method to run that initialize method and set the name, mod, and traits. Because if you look at the instructor class, right, it has name, mod, and traits as instance variables. Okay, Molly, what happens in line 5? We don't need to do line 5. Students is set to students. Name dot upcase. So the associate instructor has their own state name behavior, right? That's unique to an associate instructor because we're real excited to be here. So they say their name in upcase. And they're also responsible for counting the student select as well. Those are the associate instructor's responsibilities. And so they have extra responsibilities besides just teaching class, teaching a lesson, which they should still be able to do, right? Because they inherit from the instructor class. And also, what is the other thing in instructor class? Well, grade project, right? They should be able to teach a lesson and grade a project because they are inheriting from the instructor class. Cool, good job. Any questions on, do you want to leave your code up, Sammy, for a second? I just want to give people opportunity to ask questions if they have anything about this code. Gunnar, go ahead.
Yeah, it's not about the code, or it is technically. Do you have to, when you use a parent, like instructor, do you have to require that file in this file if you run it? Because we ran into that issue where we could run it, but we had to require the parent file.
Yeah, you might need to. I think you might need to require the file. Well, actually, do you? Yeah, I mean, if it's referencing the name of the class, which is instructor. I was able to create it without doing the require though, so I'm a little bit confused on why that is. Maybe it's because of the runner file. I had both those files defined, but I don't think you need to require. I'm trying to think of how Ruby works. How do basic require statements work in Ruby? I didn't need it, but I did need it in my runner file because I was creating new instances of it. No, I don't think you need it in the teaching assistant file or the inheriting classes file. Can you show me, Gunnar? Let's see.
Yeah, I was like, maybe it's just the way I did it.
Let's look at a specific example.
Because like we made our, I guess this is our parent file of instructor, and then we like made an anchor, and we were just kind of messing around with it. And then when I took this require away on line 1, let's just comment it out, and then I go over it because I already required it. Oh, wrong thing. In our runner, I require the instance, which is our anchor, and our parent, and I run it in my terminal. It doesn't know what the initialized constant instructor, but as soon as I go over here and I uncomment and I go back, bam, it reaches my price session in my runner.
Is it possibly the order in which those require statements are run?
How embarrassing.
Is that what it is? Yeah, I guess maybe it's the order that those are required. I think that makes sense because you load the class into, if you load the parent class first and then the child's class, it like has access to that in the runner file all of a sudden. So
that was definitely the answer. Now I'm embarrassed.
That makes sense. I mean, I didn't know either. I was like, what? I was like, how's it working in mine? I was like, I know I'm including both of them. Okay, cool. But if you had like a regular application, like you probably would like load the parent class in the child classes file using require. Right? If you had tests, you would need that sort of thing. I didn't really test for this lesson because why? But yes, you would need the require. Eagle Eye Molly. That's my best eagle screech. All right. What are some last thoughts we have here on inheritance or questions? Yes, me too. All right, in the chat, what's the criteria we decide for when we want inheritance? It passes a certain test, and we want both the blank and the blank. Can you fill in the answers for that in the chat? What are use cases for inheritance when we want it passes some sort of test? What's the name of that test? Yeah, ISA, right? And we care about passing that child class both state and behavior. Both state and behavior. Cool. That is the main walking away point I want you to get. When will we apply inheritance in these cases? Let's go back to the notes here. We're done with the code for now. I need to share my screen. Well, here we go. So finally to the why. We've done all this talking. Why do we use inheritance? When we think about how we organize our code, inheritance can help us, may help us, right? When we think about like the refactoring lesson or concepts like single responsibility principle, where a class is only responsible for one thing, inheritance is just another way of organizing our code a certain way, so it'll make sense to us. It may help us with not writing the same code. Try, don't repeat yourself. Try is just not a rule, it's just something to think about. It's like you shouldn't be writing the same lines of code, the exact same lines of code over and over again, right? So if you see same lines of code you're writing over and over again, what's a code smell? What's a code smell? Code that's stinky, ew. And so if you see the same lines of code or very similar lines of code repeated, it's a code smell, and you might think to yourself, should I use inheritance here? And then you'll go, does it pass the is a test? And do we want the same state and behavior? Then yes. By all means, use inheritance. But do not overuse, or I will hunt you. This is important that I do this. There we go. Sometimes, when you have a tool like inheritance, let's say inheritance is a hammer, then everything seems like a nail, right? Yes, let's use inheritance. I love it so much. Please, OMG. No. Do not overuse or I'll haunt you. It should pass the is a test. You want the same state and behavior from the parent to the child class, right? Dane, ask me how many times I've implemented inheritance in my professional programming career. Go ahead. Unmute yourself.
How many times have you?
0 times.
Okay.
0 times. So why are we learning this then, Bob? Well, like I said, a lot of it is how we organize our code. Inheritance may help us. It's a good pattern to recognize, right? It may help us not write the same code. A lot of it is about pattern recognition. If you see this symbol, you know there's inheritance. Well, in this case, you have one class that you're defining, and you see the symbol, you're like, your brain's like inheritance. And that way, when we call, like, let's say we had some code below, right? Teaching assistant. Let's say new teaching assistant. Has all these traits. Oh boy. Bob. Mod. Traits. Hi. Mentor. Dane. Then we call teaching assistant dot teach lesson. Right? We have this. We see that it's inheritance from the instructor. And that way we know when we don't see the teach lesson method on teaching assistant, it exists in the instructor class, right? It exists in the instructor class. It's about pattern recognition and showing you that Ruby is not magic, right? It's not magic. The only reason I need to know inheritance in the professional programming world is like, oh yeah, I see this symbol and then I see the class it inherits from. That's where all the methods live that aren't defined on here. Okay. Cool. So if I know that teach lesson doesn't work, I know to look in the instructor class and not the teaching assistant class. Will you implement inheritance in your professional programming job? Probably not. Is the pattern recognition important? Yes, it is. And we're giving you ways to think about how you organize your code, The lesson I'm teaching next lesson is on modules. How many times did I implement a module in my professional programming career? 0. What's important? Pattern recognition. And thinking of ways to organize your code that makes sense. All right. Any last questions on inheritance? Well, you better know it because the modules lesson is very closely tied to how inheritance works. Sort of.
May I ask a question?
Sure.
So a parent class can have however many children class. There's not like a limit, correct?
Yep. No limit.
Rad. Thanks.
Yeah. As many children as it wants. Sarah, go ahead.
What's the difference between inheritance and kind of the other thing we were talking about with mocks and stubs, where like you're still pulling in things, characteristics from other classes, and you're doing that in a similar fashion here, just different syntax, but you're still utilizing characteristics and things from other classes and pulling it into, right? Or am I off there?
Sure. I think that's kind of similar to the question Susie asked before, right? Here we're talking about inheritance, which has to do with we want classes that are implemented that have the same base state and behavior as the parent class does, right? When we're thinking about the World Cup example, for example, World Cup example, that has to do more with dependencies, right? The team needs instances of players to have a team, right? It might even ask team questions about itself, or players, the team might ask players questions about it. Hey, what's your salary? Hey, player, what's your name? Etc. To find out more information about the team itself. Hey, team, who's your highest paid player? Well, let's ask the player for its salary, take all those salaries, and then just return the highest one, right? It's more about interaction and dependencies. This is more about inherited behavior and state. Inherited behavior.
Pretty different. Okay, that sounds like, thank you for answering that again.
Sure, no problem. All questions are good questions, except the ones I ask myself. Lee, go ahead.
This isn't on the topic of inheritance, but it is, I feel, important. Is our schedule for the mid-mod diagnostic going to be posted today, or is that like, surprise, this is what time it is for you?
I will post in your channel and let you know.
It's up. I just checked.
It's up. That's why I'm just a teaching assistant. I can tell you the current time is 2:56 Mountain. That's it. I can teach a lesson, but it better not be longer than 90 minutes. Jenna, go ahead.
So just to give like my brain like a actual example, not to bring up Battleship, but I'm going to bring it up. So say like in the real game, there's more than just a sub and a cruiser. There's a variety of ships. So a potential way to organize like ships could be having like if you had a ton of them, you could have a ship parent class and potentially children of the different types of ships.
I would say no in the specific case of Battleship, but I like where your head's at. And this is why. The differentiators for types of ships are their length, right? Which is an instance variable. And therefore, they don't really have the same, like, they don't have extended behavior or extended attributes that they necessarily. But let's say Battleship worked like this. I'm just making it up. Ships that are a length of 2 and 3 can fire what? Well, this analogy breaks down, but let's just think about ships in general, okay? If you have a little cruiser ship that's a length of 2, maybe it can only fire at other ships 1 time. What if you have a ship a length of 3? Well, maybe it can only fire at other ships 1 time. And that's the base behavior, right? Ship, fire, can fire once. But let's say ships that are a length of 4 or more can fire twice for some reason, or 3 times. That might be a good use case for inheritance, right? cruiser, battleship, yacht. I don't know why a yacht would have guns on it, but mine will. They all can fire, but some of them can fire more because they're bigger. But at their base like level, they can only fire once. I'm the captain now. All right, Lawrence, go ahead.
Sorry to step off of that, but would it be bad etiquette to have number of times it can fire being part of the ship class? If arguments, or would that be making the ship class contain too much?
You know what? Let's not get too far in this analogy. I'm sorry I brought it up.
Got it. Thank you.
Yeah, let's remember this. Do not overuse or I'll haunt you. I'm going to haunt myself tonight because I overuse the analogy. Do not overuse. Okay? And then I'll leave you with one brain numbing example to walk away from. You shouldn't do like a square as a type of rectangle, even though they all have four sides, right? That's a length and a width, because squares have very unique properties about itself that like don't fit into a rectangle. Basically, they're like all the same size, right? They all have the same angles. Other stuff like that. So you have to be real careful. It's like it does pass as a test, and maybe there's some inherited attributes, but you wouldn't want to do a square as a type of rectangle. I can post an example of why that would be bad. Like I said, don't overuse inheritance. If it's not obvious to use inheritance, don't use it. All right. It's 3 o'clock. Goodbye.